let us define transition function formally for this language, having given the description how PDA works. So remember, if you look at the transition function of the finite automaton, we were saying we are at a state q. On reading an input symbol, say A, we go to a state q prime. And it may be more than one states if it is a non-deterministic finite automaton. But this one, in addition to the input tape, it has a stack. So we say the start symbol of the stack is Z0. It could be any symbol. Let's say Z0. Whatever we push, it will be on top of this. When we push A, it will be on top of this. And when we push another A, it will be on top of this. So like that it goes. So given this framework, let's describe the transition function of this. So to start with, we are at Q0 and we read 0, and at the start it will be Z0. So this is state, or in particular this is start state. This is our input symbol. This one is stack configuration. Okay. So on performing this, let's say I go to a state Q1, then for this 0, initially it will be Z0, then it is changed to Z0, on top of it, it is A. So which means it is A Z0. So this is our output state, then stack configuration. So if you look at the description, this is how it will be for all the description in the transition function. So we look at the top of the symbol and what happens to the stack configuration after we move from this configuration. So we move to a state called Q1, then we push A, so that is represented as A Z0. So we always represent the top two symbols of the stack, and this is our output state. So output state. So now we are at Q1. We read the next 0. Now when you are in Q1, top symbol is A. So it is this. So although I say stack configuration, it is in fact top symbol. Over here it is top two symbols if it is push operation. Okay. So yeah. Now what happens? We are at Q1. We currently have A. On top of it we push one more A. So this is what happens. So we move from this configuration to Z0, on top of it A, then we have one more A. Suppose we go through this again. Q1, we read one more 0, top symbol is A. Now that would become Z0, A, one more A. So with this, you can completely read all of zeros, meaning the first part of the input string. Okay. Suppose the input string is 0, 0, 0, 1, 1, 1, then at the start it will be this. Then when we read the first 0, we will be in Q1. Then we are at Q1, we read a 0, top of the symbol is A, then we come over here, then we are still at Q1 because output state is Q1. We read the next 0, top of the symbol is A, we push one more A. So at this point in time, the stack configuration is precisely this. So having read 3 zeros, stack is Z0 followed by triple A's, and the ones, they are still on the input tape. So now that we have read all zeros, which means what is that we do? Using this is called instantaneous description. Using this ID, instantaneous description, we read the first 0. Read the first 0. This you can apply many times. So read the remaining zeros, which is n minus 1 zeros. So we use this instantaneous description to read the first 0. Then we read this and to read the next n minus 1 zeros. And at this point in time, the stack configuration will be this. Okay. So now that we have read zeros completely, let's start with 1. So delta of, we are in Q1, we read 1, top of the symbol is A. Now we say you go to Q2, we need to perform pop, that is denoted using this symbol, which means pop top symbol. Okay. When I write epsilon, which means pop the top symbol. So I am in Q1, input symbol is 1, top of the stack is A, then we move to Q2, then pop the top symbol, which means for this one, what happens? We pop this A, then it becomes Z0 A. Now I am in Q2, read rest of the ones. Keep performing Q2 minus Q2 comma epsilon. So now what happens? For the next one, you pop 1A. For the last one, you pop this A as well. So which means for this one, 1A is popped out. For this one, this A is popped out. For this one, this A is popped out. Now we are here. Input tape is empty. Stack is also empty, meaning stack contains the top symbol. So I am at Q2. There is no symbol on the input tape and top symbol is Q0. At this point in time, I accept, let me say, go to final state. You may take out the Z0 or you may retain the Z0. Both are allowed. So which means reach final state and accept. Meaning reaching the final state itself, it says accept. Okay. Or one can also write QF comma epsilon, which means even this Z0 is also removed. Both are acceptable. Both are in fact equivalent. So one says you reach the final state and accept. This says you also empty the stack and accept. Okay. But irrespective of this, we know when we are at this stage, we have seen equal number of zeros and equal number, meaning we have seen n number of zeros followed by n number of ones. So which means for every 0 there is one corresponding 1. That's very important. For every 0 there is one corresponding 1. And in fact we don't keep track of the count whether we have read 20 zeros or 20 ones. For every 0 there is one corresponding A. And with that we ensure there is one corresponding 1. So 0 to A to 1 ensures for every 0 there is one corresponding 1. And so finally when you reach this configuration, you are at Q2 and you have exhausted the input tape, and the stack contains Z0, which was our start symbol, which means zeros and ones, there is a match, and you can reach the final state and accept, or you can also empty the stack and accept. Fine. And now it is a function, so which means there are other IDs which one has to write so that it becomes a function. Right now what we have written is Q0 reading a 0, it goes to Q1, Q1 reading a 0, it goes to Q1 again, and Q1 you read 1, you go to Q2, Q2 if you read 1, you go to Q2. But there may be inputs like 1011, 0101. So those inputs have to be rejected because input can come from sigma star. And so this only captures the valid inputs, and there are other inputs which are invalid. They have to be rejected by the automaton. With that it becomes a function. So let's write that as well. So far we have seen delta of Q0, 0, Z0 is Q1, A Z0. Delta of Q1, 0, A is Q1, AA. So this take care of push. Then delta of Q1, 1, A is Q2, epsilon. Then delta of Q2, 1, A is Q2, epsilon. Then delta of Q2, input is empty, top of the symbol is Z0, then you reach the final state. Okay? You either write this or you say QF, epsilon. So this takes care of pop, and this is accept part. And along with this, there are other transitions. For example, I am in Q0. Instead of reading 0, I am reading 1. And language says it should start with 0, but suppose the input is 1011. This is an invalid input. And you are at Q0, you are reading this, so this has to be rejected. We say we go to a non-final state, something called QNF, or you can even write QR. There is a state called QR reject, and stack symbol, let it be Z0. So when I am at Q0, I read a 1, then it must be rejected. On reading 0, it's fine. When you are in Q1, you read a 0. When you are in Q1, you read 1. So both are taken care of. So now I am at Q2. When you are at Q2 and you come across a 0, and top of the symbol is say A, because you must have read some A's. Even this has to be rejected. Okay. So I go to QR. Now you are at Q2. You read a 0. Top symbol is Z0. It could be A or Z0, right? So I am writing both. And both have to be rejected. So I go to a reject state. So something like this. is say 0 0 and 1. Let's assume 000 followed by 1. Now for this, you see that you have pushed 3 A's onto the stack. Now you read a 1. When you read a 1, you pop, you stay in this. Let's assume the next symbol is 0, which means you are at Q2, you read a 0, top of the symbol is A, then it has to be rejected. Or let's assume it is 00 followed by 11, then this. Now for these two zeros, it will be this. Then for these two ones, you pop them, which means this is what will happen. Now you are at this stage, which means you are at Q2, you are reading 0, top of the symbol is Z0, this has to be rejected. I am giving you an example, invalid string, and which will depict these two. Meaning, suppose the input is this 0 000 followed by 10, and first 0 you read and you push, you go to Q1, then you push one more A, you are in Q1. Then Q1, on reading 1, you go to Q2 and pop 1A. Then you go here, you are still in Q2. You are in Q2, you are reading a 0, top of the symbol is A, so it has to be rejected. So we go to QR. And top of the symbol could be A or it could be Z0. Look at this input, 0011. So after that a 0 comes, which means you are at Q2, reading 0, top of the symbol is Z0, it has to be rejected. So when you are at Q2, if you read a 0, irrespective of the top symbol is A or Z0, it has to be rejected. So now along with this, one should have these IDs as well, so that invalid inputs are rejected. Something that starts with 1, it has to be rejected, and after reading 0, say 1, you read a 0, that has to be rejected, and you have seen zeros and ones. After that you come across a 0, then that has to be rejected. So all are taken care of. So with this, you see that the transition IDs are complete. Okay, so now a formal way of writing how the machine works, here is the way to write. Okay. Now there are other states, right? For example, you are in QF, you say it is accept, and you are in QR, which means the input is invalid, and you reject. One can also write the transition like you are at QR and you come across a 0 and start symbol maybe Z0, again this has to be rejected. Or you are at QR and top symbol is A, it has to be rejected. Or you are at QR, you read 1, top symbol is Z0, it has to be rejected. And delta of QR, comma 1, comma A, again this has to be rejected. Okay, because I am in reject state, you come across some more zeros or ones, and one can even write description for that. With that you say it is rejected. Okay, and because being a function, one has to write all possible IDs, which is why we have written all of them. Okay.